Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 21 to 24 of the Geometry Common Core Regents exam for June 2015. All right, let's take a look at problem 21. It reads, in the diagram below, triangle ABC is similar to triangle DEC. If AC equals 12, DC equals 7, DE equals 5, and the perimeter of triangle ABC is 30, what is the perimeter of triangle DEC? Now, one thing you want to note is that the proportionality of sides of similar triangles, something that's a fact with similar triangles, the proportionality of sides also applies to the perimeter. Okay, so whatever that constant of proportionality is for the sides, the same applies to what the perimeter of the two triangles are. Okay, so the steps we're going to use are as follows. First of all, we're going to write the similarity statement reflecting what I just said to note here. Compare the proportionality of the sides and the perimeter of the two triangles. Then in that statement, we're going to list the measures we know and the measures that are unknown. Basically the ones that we have to find. We'll substitute the known variables and then isolate the one that's to be found, all right? Okay, so before we write up our statement, let's go ahead and label our two triangles. AC as the longest side of the bigger triangle. That side is similar to DC, the longer side of the smaller triangle. And then DE as the next side for the smallest triangle, that's 5. And that's basically all we have. And then we're told that the perimeter of triangle ABC, the bigger triangle, is 30. And we're asked to find the perimeter of the smaller triangle. Okay, so now let's go ahead and write a statement about the proportionality of the sides and the perimeter. Okay, so we know that for similar triangles, corresponding sides are in proportion. Guess what? The perimeters are in proportion in that order also. So what side corresponds to DC? In triangle ABC, what side corresponds to DC? AC corresponds to DC, right? So we can say that DC over AC, okay, let me show it to you. DC over AC, the ratio of the longest side of the small triangle to the longest side of the bigger triangle is equal to, guess what? The perimeter of the smaller triangle, which is triangle DEC, is equal to the ratio of the perimeter of triangle DEC. Let me write down the whole word so no one gets confused. Perimeter of triangle DEC divided by what? Divided by the perimeter of triangle ABC. Okay, so we see that corresponding sides are in proportion and the perimeters are in proportion with the same ratio. Note, this does not apply to area. Let me write that on the side. Note, as a warning, this does not apply. This does not apply to area, okay? Because area is a square, whereas perimeter is just a side. So we're looking at different dimensions here, okay? So you can only make these statements with perimeter. You can't say the same with area, okay? All right, there's a different formula for that, but we're not using that for this problem. So let's write down what we know and what we need, and then use this equation right here to find what we need, all right? So we know that on DC, the length of side DC is 7, We know that AC is 12. What else do we know? We know that the perimeter of, what is the perimeter of triangle DEC? What is the perimeter of triangle DEC? That is what we're looking for, okay? So put a question mark there. And then the perimeter of triangle perimeter of triangle ABC is what? 30. Perfect. So we have just one unknown. If we substitute these values, the known and the unknown, into this statement right here, this proportional statement, we're going to have 7 over 12 equals the ratio of the perimeters, perimeter of, I can write it in short now, perimeter of triangle DEC divided by perimeter of ABC. What is the perimeter of ABC? That's 30. Okay, so what are we looking for? We want to get the perimeter of triangle DEC by itself. We accomplish that by simply multiplying both sides by 30. Okay, if you multiply both sides by 30, you just plug it in your calculator. Perimeter of triangle DEC. Let's see what the result is. So we are computing, what are we looking for? 30 times 7 divided by 12. 30 times 7 divided by 12, 17.5. That is the area, I'm sorry, that is the perimeter of triangle DEC. Answer is option number 4. All right, let's take a look at problem 22. It reads, the line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? Now, one thing you want to remember is that the slope of a line is preserved, basically remains unchanged under dilation. Okay, so when we're looking at the resultant image after the dilation, the line that is the image is going to have what? It's going to have the same slope as the original. It's going to have the same slope as this line right here. Okay, so keep that in mind. Steps we're going to use to solve this problem are as follows. First, we will write this given equation in y equals mx plus b form, slope-intercept form. Why? Because it helps us to find m, the slope. Okay? After doing that, we are now going to find the slopes of all these options right here, the different ways you can do it. I'm going to use the y equals mx plus b form, convert them into y equals mx plus b form, and use that form to find the slope. And then whichever slope in the 4 options matches the slope of the original, that is your answer. Okay? All right, let's go ahead and do it. Step number 1, we have the original equation, 3y equals negative 2x plus 8. We want to find the slope here, so we want to put it in y equals mx plus b form. So we can do that in one step. Simply divide all 3 sides by 3. And then we have y isolated equals negative 2/3 x plus 8/3. Okay, so what's the slope? Slope is the coefficient of x. Remember y equals mx plus b. This is m. So the slope, which is m, is negative 2/3. Now, if the slope is negative 2/3, so what? The slope of the image must also be negative 2/3, right? So let's just write a real quick remark. Since the slope of a line is preserved under dilation, the slope of the image image of the given line must be what? Must also be negative 2 over 3. Okay, so what does this tell us? We just look at all these options. Whichever yields a slope of negative 2 over 3, that is the image of the dilation of this line. Okay, so let's start with option 1. 2x plus 3y equals 5. We can get this in y equals mx plus b in 2 steps. Subtract 2x and divide by 3. Okay, let's go ahead and do that. Subtract 2x. That yields 3y equals negative 2x plus 5. And then to get y isolated, divide everything by 3, just like we did in the original equation. And that gives us the slope-intercept form, y equals negative 2 over 3x plus 5/3. What's the slope here? The slope, which is m, is equal to negative 2/3. So what does this mean? Is this the image? Absolutely. Why? Because it's the same as the slope of the original. We are done. Okay, so answer here is option number 1. If you go ahead and find the slopes of all the other lines, you find out that they're different from negative 2 over 3. Okay? Okay, let's move on. Okay, let's take a look at question number 23. It reads, a circle with radius of 5 was divided into 24 congruent sectors. The sectors were then rearranged, as shown in the diagram below. To the nearest integer, the value of x is... Now, one thing you want to note is that the circumference, the formula for the circumference of a circle is 2 pi r. Okay? Now, the steps we're going to use to find x are as follows. First, we will relate the dimensions of this circle to this final shape right here, whatever that is. Okay? Then, we're then going to write down the formula for finding the circumference of the circle. Then we're going to use the circle, the measures for the circle provided to find out what the circumference of the circle is. Now that I have the circumference of the circle, we'll use that along with the relationship between these two shapes. The statement we came up with in step 1, we're going to then use that and the circumference to find the value of x. Okay? All right, so step 1, that's where most of the work is. What is the relationship between the dimensions of this circle and this shape, this figure? Well, let's take a look at each sector. The distance from the center to the circumference, what is that segment called? The length of each sector, that is the radius. Okay, so if you take a look at this figure right here, do you see the radius? The radius is right here. You see the line, this line right here? That's the radius. That's the radius. Okay, so for this shape, for the circle, this is the radius, this right here, that's the radius. And then for this figure right here, from here to here, that's the radius. Okay? And what is the radius? Radius is 5. Alright, now, is there any other relationship that we can decipher from these two figures right here based on what's given? Absolutely. Let me go ahead and mark my radius. Okay. The next relationship between the dimensions has to do with the circumference. Now, watch what happens. For this circle, the circumference is the distance all around, from here all the way around. Oh snap, it's so crooked, sorry about that. Distance from there to there, that's the circumference, that's C. Okay, now what happened here? We have a total of 24 sectors, congruent sectors, they all equal area. Okay, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 on top, 12 on the bottom. So what was done to this circle? It was split in half. So what do you think is going to happen with the circumference? If you split it down the middle, what is this distance going to be right here? That's going to be equivalent to the circumference divided by 2 on top. And then how about the bottom right here? What is that going to be? That's going to be circumference divided by 2 also. Okay? Now take a look at this. When the figure was then, the sectors were then aligned in this orientation. So you have this distance right here, 3, 4, 5, 6, 7, 8, 10, 11, 12. What's that distance? That distance is still the circumference divided by 2. Okay, you just add all those little pieces together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see how that is the same thing as going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing. And then it's the same thing here too. Circumference over 2. The same story with the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What does that measure? That measures C over 2. And then the same figure was then stacked, it was moved together, okay? They just meshed them together. So you have this figure right here. So what is x? What is the distance from here to here? Guess what? It is C over 2. All right? So that's the relationship. This distance right here, the height, is the radius, and then x is C over 2. So this is the relationship that we are going to be using because it helps us find C. I'm sorry, it helps us find x. So x is C over 2. Perfect. Now, step 2, we're going to write down the formula for the circumference of a circle. Remember, that's 2 pi r. And then we're going to use the provided information to find the circumference, okay? We're told that the radius is 5. So we plug 5 in here. 2 pi multiplied by 5, you get 10 pi. Okay? So the circumference is 10 pi. Now that we know C, we can then combine it with this statement to find x. Okay, so let's substitute 10 pi for C in this equation. That gives us x is equal to 10 pi over 2. All right, and let's plug this into our calculator. So we are computing 10 pi divided by 2. And then we're rounding, well, let's write down what our answer is. So what is x? X is approximately, where did my calculator go? It just disappeared. 15.708. Okay. Now we're asked to round it to the nearest integer. So if we want to round it to the nearest integer, we're rounding it to the ones place. So this is 5 or greater, so we're just going to carry 1. So this is going to be 16 to the nearest integer, to the nearest integer. So our answer is option number 2. All right, let's take a look at number 24, the last multiple choice question in this installment. It reads, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Now, a real quick reminder is that the postulates and theorems that can be used to prove that two triangles are congruent are AAS, SSS, SAS, ASA, and the HL theorem. All right, all these symbols basically means that the sides are congruent and the angles are congruent. Okay, and following the order. All right, so steps we're going to use are as follows. We're going to take a look at the statements here. We're going to translate them into a statement using just S and A or H and L. Okay. Then whichever statement matches any one of these options right here, that will be sufficient evidence to prove that these two triangles are congruent. Okay. All right, let's start with number one. AB is equal to DE, BC is equal to EF. What is that? That is the first statement side, second statement side. This is SS. Is SS sufficient to prove that two triangles are congruent? Absolutely not. We need three sides, SSS, okay? All right, let's take a look at number two. We have angle D congruent to angle A, angle B congruent to angle E, angle C congruent to angle F. This is A angle, A angle, A angle. Is AAA sufficient to prove congruency? Absolutely not. All right, let's move on to option 3. It reads, there is a sequence of rigid motions that maps AB onto DE, BC onto EF, and AC onto segment DF. So basically the rigid motion, you can basically place this triangle perfectly on top of that one. Okay, perfectly. So let's see what is given here. Even though you might not really understand what rigid motion and mapping is exactly, some of you might, but let's just keep it simple. Okay, AB congruent to DE, what is that? Side. BC congruent to EF, what is that? Side. AC congruent to DF, what is that? Side. What is this? SSS. Is this sufficient to prove that two triangles are congruent? Absolutely. So this is the answer, option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found this tutorial helpful to you, please give us a thumbs up and share it with your friends. We really appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about the Geometry Common Core Regents exam, if you need help, just place your question in the comment section below and we'll be glad to help you as soon as we can. Don't forget to test yourself with our interactive practice tests accessible here. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.